Welcome to today's deep dive. I'm really excited about this one.
Yeah, it's a great topic today.
So, to everyone listening, we are unpacking a single, really fascinating field note from a hobbyist named Ang.
Right.
Specifically, it's titled Notes on Fishkeeping, Part 268, and it was published on June 6th, 2026.
Which, just sounds like a standard journal entry at first glance.
It totally does. The setup
Yeah.
seems completely mundane. We're talking about a simple trip to an aquarium store, right?
Yeah.
But it quickly spirals into this incredible biological mystery involving mistaken identity, artificial intelligence, and a creature with this wildly complex, shape-shifting life cycle.
It's amazing how the best nuggets of knowledge often hide in the mundane observations of a really dedicated hobbyist.
Oh, absolutely. I mean, we rely so entirely on labels to navigate complex systems. You walk into a specialized retailer, you look at a tag on a product, and you just assume that categorization represents an absolute objective truth.
Because we want the world to be organized.
Exactly. We pay retailers to do that organizing for us. So if a label says Red Scat, complete with a neat little scientific designation right underneath it, you trust it.
But that neatness is often a complete illusion, especially when you are dealing with living organisms.
Right.
I mean, retail commerce requires static, unchanging categories to function efficiently. But biology, on the other hand, is dynamic. It's messy. It's constantly in transition.
Doesn't care about a barcode.
Exactly. When you pit a rigid retail label against the biological reality of a living creature, the label is usually going to lose.
Which brings us to Ang's discovery. So Ang is walking the aisles of a local aquarium store and spots a tank labeled Red Scat. The scientific name on the tank is Scatophagus rubrifrons.
And this is an exciting follow-up for Ang.
Yeah, because back in an earlier journal entry, I think it was part 244, Ang documented finding a related species, the silver scat.
Right, the Selenotoca multifasciata.
Finding the red scat feels like completing a set.
There is a real sense of continuity for the hobbyist here. The label is right there on the glass, providing that clean retail certainty we just talked about.
But Ang doesn't just accept the fact. Ang takes a photo of this fish, goes home, and while drafting this journal entry, decides to run the image through an AI analysis tool.
And this is where the twist happens.
Right. Okay, let's unpack this, because the AI completely disagrees with the store's label. It scans the photo and determines that this is not a red scat at all. The AI says it is a spotted scat, scientific name, Scatophagus argus.
It's such a fascinating collision of authorities.
It really is. It's like, okay, imagine going to a nursery and buying what you think is this rare exotic houseplant, right?
Right.
You get it home, you're super proud of it, and then you use one of those plant identifying apps, and it tells you, nope, that's just a common, cleverly disguised weed.
Yeah, that's a perfect analogy. And if we connect this to the bigger picture, it highlights a real tension. On one side, you have the physical retailer carrying the traditional weight of specialized commerce.
Right.
On the other side, you have an algorithmic analysis, processing millions of data points. And caught in the middle is the hobbyist, trying to figure out which system is actually telling the truth.
See, but I have to push back on the AI immediately, though. If I in Ang's shoes, I am highly skeptical of the app.
Oh, for sure. AI hallucinates all the time.
Exactly. Image recognition software can be thrown off by, like, the weird fluorescent lighting of a pet store, or the refraction of the aquarium glass, or literally just a bad camera angle.
Yeah, the AI is simply matching pixel patterns. It doesn't possess actual understanding.
Right, so why should we, or why should Ang, put any faith in a piece of software over a specialized aquatic retailer who handles these animals every single day?
Well, that skepticism is entirely justified, but you also have to interrogate the retailer's authority. I mean, how does a fish get its label in a store?
Someone prints it out and sticks it on the tank.
Right, but the local retailer isn't conducting genetic sequencing in the back room. They're almost certainly just copying the name off a wholesale invoice.
Oh, I see. They're relying on the supply chain.
Precisely. A commercial distributor, who is possibly continents away, scoops thousands of juvenile fish into bags, slaps a label on them based on a cursory glance, and ships them out.
Because they're incentivized by speed and volume, right? Not taxonomic accuracy.
Exactly. And Ang actually explicitly notes in the journal that fish stores having a tendency to mislabel species is a widely recognized issue within the fish-keeping community.
So the retailer's label isn't a scientific conclusion at all. It's just a game of commercial telephone.
Yes, exactly. So you have two highly flawed systems of identification. The supply chain is prone to human error, and the AI is prone to algorithmic hallucinations.
So to break the tie, Aang has to abandon both the label and the app. Aang has to actually look at the physical creature in the photograph.
Which requires moving past the broad strokes of categorization and really intensely focusing on the anatomy in front of you.
Right, so let's look at the visual evidence provided in Aang's photo. Why did the AI and the author conclude the store was wrong?
Aang observes this specific distribution of color and pattern.
Yeah, Aang notes that the red coloration on this fish is incredibly minimal. It's restricted almost entirely to the dorsal fins, just that top ridge of the fish.
And meanwhile, the vast majority of the animal's body is covered in distinct, unmistakable spots.
Right. Therefore, it is far more likely to be a spotted scat. Because the spots dominate the physical real estate of the fish, Aang sides with the AI.
It is a process of weighing the dominant morphological features against the superficial ones. Aang uses deductive reasoning to override the commercial label.
But let me play devil's advocate here regarding that visual evidence. How much of a single color does a fish need to have to earn its name?
That's a fair question.
I mean, think about it. If a bird has a red breast, we might call it a robin. If a fish has a bright red dorsal fin, even if the rest of it is spotted, why is Red Scat an invalid name?
Well,
Who gets to dictate the threshold for these common names? Like if I paint the front door of a house red, it is a house with a red door, right?
you are hitting on the fundamental flaw of common names in biology. They are notoriously unreliable because they are rarely rooted in scientific systematic structure.
What do you...
They are usually just historical accidents. Imagine a 19th century merchant or an early explorer pulling a fish out of a river. The very first thing that catches their eye is a flash of red on the fin before the fish loses its color in the air.
Right, so they just jot down Red Scat in a ledger.
Exactly. And that commercial shorthand sticks for a century. The common name reflects a momentary human perception, not the genetic lineage or the dominant anatomy of the species.
Okay, that makes a lot of sense. So going back to the house analogy, if you have a massive, intricate Victorian mansion, but the front door is painted blue, you don't call the architectural style a blue door.
Right, you don't.
You call it a Victorian.
Yeah.
The spots on the fish are the architecture, the fundamental structure of its identity. The red fin is just a superficial paint job on the door.
That is a much more accurate way to look at it. And the scientific nomenclature actually supports Aang's visual analysis.
Also,
The term Scatophagus argus for the spotted scat is revealing. Argus, in Greek mythology, refers to a giant with 100 eyes.
oh, wow.
Yeah, which translates biologically to a creature covered in eye-like spots. The scientific name aligns with the dominant architectural feature Aang is observing. The spots are the defining trait, not the marginal red fins.
Okay, so Aang has effectively debunked the store's label using a combination of AI suggestion and rigorous visual analysis. But here's where it gets really interesting.
Because we still don't have 100% proof.
Right, Aang introduces this massive biological hurdle into the journal entry. Aang writes that despite the overwhelming visual evidence, they can never be absolutely certain of this identification.
Because you can only be certain when the fish reaches maturity.
Exactly. And Aang notes that in the context of this hobby, that is highly unlikely to happen in this setting.
This is where the story shifts from a simple case of a mislabeled product to a profound look at the biological realities of these animals.
Yeah, because we are dealing with juvenile morphology.
The spots in the red fins we are debating, they are temporary. They are the traits of an infant, and those traits can change drastically as the organism matures.
Aang drops two highly specific, fascinating scientific terms into the notes to explain why this maturation process is so complicated. Aang describes these scatfish as being both euryhaline and amphidromous.
Those are two of the most demanding biological classifications an organism can fall under.
Let's break down exactly what this means according to Aang's notes.
Yeah.
Starting with amphidromous.
Okay.
An amphidromous life cycle means the fish's existence is physically split between two entirely different aquatic environments.
Right.
They spend their juvenile years, which is the phase where they are scooped up and sold in these freshwater aquarium stores, living in freshwater rivers or estuaries.
But as they grow into adults, their biology compels them to migrate out into the saltwater ocean.
It's like, imagine a teenager growing up in a small, quiet, freshwater town, you know?
Right.
But eventually, the moment they reach adulthood, they have to pack up and move to the massive, salty ocean of the big city. They literally can't stay in the small town.
It is a geographic and physiological destiny. They cannot remain in the freshwater environments of their youth if they are to reach their full, mature adult forms.
Which brings us to the second word, euryhaline. This is the biological mechanism that allows the amphidromous migration to even happen.
It is incredible.
Right, because if I take a normal freshwater fish, like, say, a goldfish, and drop it into the ocean, it dies almost instantly. The salt sucks the water right out of itself.
Yes.
But a euryhaline fish has the internal machinery to survive in both fresh and salt water.
To understand how extraordinary that actually is, you have to look at it on a cellular level. In a freshwater environment, the fish's body is far saltier than the water around it.
Okay.
Basic osmosis means water is constantly flooding into the fish's body. To avoid essentially exploding, a freshwater fish has kidneys working in overdrive to excrete massive amounts of water while desperately holding on to whatever salt it can.
It's constantly bailing water out of the
Yeah,
body.
exactly. But when that same fish migrates into the ocean, the physics completely invert. The ocean is far saltier than the fish.
So suddenly the water is being aggressively sucked out of the fish's body.
Yes. To survive, the fish has to start drinking seawater constantly, and its gills and kidneys have to completely reverse their function. They have to pump heavy amounts of toxic salt out of the blood while retaining water.
That is insane. It is like, okay, imagine driving a complex machine, let's say a submarine, through a freshwater lake, right?
Okay, I'm with you.
All the internal pumps are designed to push water out of the hull. But the moment you navigate that submarine into the ocean while you are still driving it, you have to completely rip out the plumbing, reverse all the pumps to pull water in, and simultaneously build a high-capacity desalination plant in the engine room just to keep the crew alive.
And these fish do this biological retrofitting automatically as they mature.
That just blows my mind.
That reversal of the internal plumbing is the euryhaline adaptation. It requires an immense amount of biological energy and a complete physiological restructuring.
Wow.
The juvenile fish that Aang is looking at in that small freshwater tank possesses the dormant genetic blueprint to execute that massive internal overhaul.
And that leads to the ultimate irony of the author's hobby. Aang admits to never having seen a large, mature, adult scatfish.
This raises an important question about the hobby itself. Think about the implications of that statement for the entire freshwater fish-keeping community.
Yeah.
They are dedicating immense time, money, and care to these animals, yet they are essentially observing a transient juvenile phase. They are structurally locked out from ever seeing the biological culmination of their efforts.
You're curating a waiting room.
A waiting room for a creature destined for a completely different world.
That is exactly what the freshwater aquarium really is for these specific species. The hobbyist buys a juvenile, argues over whether the spots or the red fins define its identity, and meticulously maintains the water chemistry. But they are maintaining an environment that the fish is biologically programmed to outgrow.
The fish's true identity, its final adult morphology, the fully realized version of either Scatophagus rubrifrons or Scatophagus argus, is intrinsically tied to the saltwater ocean.
Right.
But because the vast majority of these freshwater hobbyists do not have the resources or the capacity to simulate a massive shifting marine environment, the fish remains in a state of arrested development.
A suspended identity. The fish is forever held in the preamble of its own life. It has the internal submarine pumps ready to reverse, the euryhaline machinery waiting to activate, but the environment never changes.
So the trigger is never pulled.
The hobbyist is intimately familiar with the animal, yet remains a complete stranger to the adult it was supposed to become.
Which brings us back to why Aang can never be fully certain of the label. You cannot definitively categorize a book if you are only ever allowed to read the first chapter.
Right.
The visual evidence of the spots and the AI's analysis are the best tools available in that juvenile phase, but they're still just analyzing an incomplete form.
But, despite confronting this biological dead end, Aang's reaction is incredibly grounded. There is no frustration about the limits of the hobby. Aang concludes the journal entry by writing, "Nevertheless, it is always great to learn something new during these trips."
It speaks to a very mature philosophy of observation. The value of Aang's deep dive into this mislabeled fish wasn't about achieving a rigid, unassailable truth.
No, it was about the process.
Exactly. Aang looked at a commercial label, recognized its flaws, utilized new technology, observed the physical anatomy, and traced the biology back to its oceanic origins.
The knowledge gained along the way is the reward, even if the final categorization remains slightly out of reach. So what does this all mean for you, listening right now? Whether you are prepping for a meeting, analyzing a data set, or just shopping at a pet store, looking closely at the details and questioning the labels we are handed is a genuinely valuable skill.
Because we move through our days surrounded by labels. Categories assigned by retailers, organizational structures at work, societal definitions.
And it is very easy to accept those labels as the final word because, well, it makes navigation simple.
But choosing to actively interrogate those labels, to look closely at the spots when the tag insists on red, is how you uncover the underlying mechanics of the world.
You begin to see the supply chains, the historical accidents, and the complex realities that the clean, simple labels are designed to hide.
And as you carry that practice of observation forward, I want to leave you with one final provocative thought to mull over on your own.
Okay, let's hear it.
Building strictly on this concept of migration we've discussed, we know these amphidromous fish possess the mechanical ability to radically alter their internal biology to survive the harsh transition from fresh to saltwater.
Right, the plumbing reversal.
Right. But consider the psychological and behavioral transformation that must accompany that physical shift.
Oh, wow.
Since these fish must physically relocate from freshwater tanks or rivers to the massive saltwater ocean as they mature, how might their behavior, their identity, and their entire way of existing transform in that harsh new environment?
That's a wild thought.
It's a massive shift. What dormant instincts awaken in the deep water? A transformation that the dedicated freshwater hobbyists who raise them will never get to witness.
It fundamentally changes how you look at the beginning of any journey, knowing you may never be equipped to understand the destination.
It really does.
Well, thank you for joining us for this deep dive into Aang's field notes. We highly encourage you to keep your own notes on the fascinating things you discover in the world. Challenge the neat categories you encounter, and pay close attention to the details hidden right in front of you.
The complexity of the whole ocean can sometimes be found in a single mislabeled tank.
Until next time, keep questioning the labels.